Hello there, Just Will here again, and today I'm just going to go over sort of a tutorial on how to use the in-game program system. Now, I'm nowhere near an expert as some other people are on this. I'm still getting the hang of it, but I want to just break down to sort of beginning systems. MIPS, which stands for Microprocessor Without Interlock Pipeline Stages. So supposedly it's a standard from a programming language that was introduced in 1985, so it's got a bit of history to it. So, basically, I'm gonna do chapter markers on the video so you'll be able to skip through to all the different stages and sort of breaking it down into stages so you can then skip through to individual parts as and where you want to. So let's get started. So I'm going to start off by going through how actually you interact physically with the chips first before we start doing too much programming. So originally I only had this one option, which was the circuit housing. In here, or IC housing as it is in game, this has lots of screws around the edge. These are identifiable to each device, so depending on what you were connected to on your circuit, you'd have these screws and you would set them to things like LEDs or sensors or anything you fancy, basically, to get the information out of them. And we'll go over that bit, how to read that later. So just the physical stuff first. So these all tally up with a particular device. So whether or not that's a auto miner or, well, a tank, it could be sensors, it could be screens, any individual device. Each one of them can be associated with one of those screw terminals, and they are listed from D0 to D5. The next option we had was the AMI system, which has a chip on the top. Now, I'm not 100% sure what the AMI bot program-wise you could do. I guess you could give it simple parameters, where it would go, things like that. I've never really actually done anything too much with these. Later on, we've now started to see devices, and this is where the game potentially is going to start heading for. So each device will have its own IC slot. So in here there will be a chip slot with 2 ports where you can program. So they're a bit more limited compared to the housing, but you still got some flexibility. You can also read off from the device with reference of DB. Again, we'll look at that a bit later with the program itself, so you don't need to assign one of these to the device it's actually plugged into. So effectively this could be 2 separate things outside. It could be an LED, could be a screen, and this one could be a speaker to say when certain things are going on. And each one of these have got a slot with 2 screw ports on them. We also have the combustion centrifuge, which has got the same thing in it. So this is the new ore system, where you've got lots of controls, things like that, to get them more ores out of the deep core mining, or the deep ore mining system. This system has been introduced so that when you hit the bedrock, you will continuously get a low level ore material out of it, basically, but we won't worry too much about that. So the next thing is, how do you actually begin programming? So there are some in-game tutorials things in here under logic devices. You can basically go through and start working out some of the basics in here. Now, the tutorials have gotten better in recent times, but it's still not what I'd call beginner friendly, because how on earth or where do you even look for how to program? So to get started, first thing you'll need is a programming system. So that can be a computer with a motherboard in it, and the motherboard is the IC editor. Or you can also use a laptop. So the laptop can have the chip inserted into it. You also need to, there we go. In the laptop there is the program chip, a battery, and the motherboard. So we can take the motherboard out of this, pop that in here, pop in a battery, and you can then program on the go. I'll set this up now and just show you this as well. Here we are, that's now set up. So on here you can see the same sort of screen we had on the computer screen. Nearly forgot to mention actually how you get the code onto the chip. So that is as simple as import and export. Import will read the contents of the chip off into the editor, and export will copy it out. You can also, with the computer version, and I'll bring it up quickly, you can have multiple programmers. So on here you can see I've got filtration and IC housing. So I can actually program the chip directly on each device. So if I want to say program that chip there, I can basically import the code, see it all here, and just say, right, I want to go in, take out, I don't know, the debugging code I put in here, confirm, export it out, and that has now updated the chip directly in the machine. So I haven't got to put it into a special housing. You can literally edit it directly on it. So this is how you actually get the editor interface in game. Now you click the edit button and you get a full screen thing come up. At the moment this is my smart atmospheric script. There are some in-game bits of tutorials here. So this is where you actually find some of the program bits. So in here we have the slot variables. So the slot variables, this refers to individual slots in a device. So that could be things like the cartridges in this filter. That could be seeds in a plant tray or in a planter. It could be states of battery in a device. There's quite a few things that basically when you look at a device, so in here you've got the Amy bot and there's lots of slots in here, and from that you can get different information out of it. And you can see down here's logic slots. Again, this is what's available on this device. So you can see charge is only available on slot 0 because that's a battery. The other ones are to do with what's in there, if it's damaged, things like that. The other function is device variables, which again, things like activating it, modes, colors, things like that. But this is all dependent on the device you are programming. So you do have to sort of come out of here, go into here, say we want to program an LED, find up the LED, and in here you can see we have the options of color, lock, on, power, things like that. So this is where you find out what these devices actually can do. So that's gets you an idea where these variables actually come into play. Because this shows you in here, this shows you all the device variables and every single thing. So things like halves isn't obviously valid for an LED. So this gives you an explanation of what it does, but again, it's not that much more useful. This information you can get through the Wikipedia or the Stationpedia, the F1 menu basically. The last one is the function one. This one is one I tend to use the most. In here you have lots of information about how to program different things. Now MIPS is a bit more of a complicated, well, I say complicated, it's more machine code than what I'd call object-oriented language, which is what I tend to do in my other spare time, things with Arduino, things like that. This is very much single thread, single logic system, mind you, so is an Arduino, so probably better like a Raspberry Pi, Python, things like that. So you have to kind of think of these lines, and they're not very function based. So this is kind of function, but you can jump it in different places and things like that. So it's very much jump to this line, jump to here, do this, do that type of logic to the system. So it's a little bit confusing to say the least, because it's, from my point of view, it's a different way of programming basically than what I'm used to. I'm used to saying jump to this function rather than jump to a line. So it took me a bit of getting used to say the least. So the first thing you want to worry about, I'll keep this on screen so we can go through it. So you have what they call aliases. So these are what you can basically set a text description of a item, a register, anything you like basically. So you haven't got to sit here going R1, R2, R3 or R0 or D1, D0, DB, things like that. So you can say set the alias of DB to filter. So DB being the device, I've set that to the variable of, or description of filter. Same thing again with here again, alias DB that. Then you got things like L, which I'm going to quick look on here because I can't remember half of them I've done. I think this was loading in a variable to the register. So you don't store things in a traditional variable system as such. So yeah, so we'll load this device variable into the register. It's not a very good description in here because it's not really showing the things. So R being the register, which is your memory storage location, basically where you want to store that information. D is the device and the variable you're grabbing from it. So in here you can see I'm grabbing ratio nitrogen input. So that's the thing we spoke about here, which is the device variables. In here you can load in different information from it and bits like that. So these ones here are loading the slot variable. So in the device, from that filter, I want to get 0 and 1. They are the individual cartridges. So I'm loading them into register 1 and 2. So basically this is reading in the information from the devices. Here I just do a simple add. Here I'm setting some things. So these are just debug flags. So I'm setting the device that is on D1 to its mode 0. and I'm setting the debug setting to that. I can't remember exactly what, but that's basically what they're doing. I'm not quite sure why I did that, but anyway. So on here we've got branch line 2, which basically, if the branch, or if R3 is less than 5, we then go over to the, or I say branch, it's more of a jump to error state. So it goes down here and it starts doing this code here, and then at the end of here got jump back to start, so it goes all the way back to here and starts going through it all again. You've also got this one here, which is branch if equals 2 equals 0. So if this is equal to 0, we could just stop, and that just goes to this one here. So again, all the information is in here. This is probably your best bet to start digging through things like that. So sort of give you an idea of what the different things are. It's all about branching and jumping and things like that. There are things in here which are to do with mathematics, so you've got like tans and sins and things like that, and registers or ands and things like that, so you can just do the if this then that type of methodology. You've got options like this where it says branch to relevant line. Now I'm not quite sure how exactly when I want to do this, because basically you're saying, oh, branch it to this number that I set from this thing here, which seems a bit, it might be used for some things. Again, my program knowledge is not always the best when it comes to this stuff, but I'm guessing it comes in quite useful. I guess if you want to do array index and things like that, but yeah, not 100% sure really. So anyway, that's sort of an overview of what these sort of things are trying to do. Now, as I'm trying to explain this, it's not easy, is it? Let's be honest. This is kind of a little bit confusing. You do get some IDE stuff, so if the cut things aren't right, it goes in red, but it's not always the most easiest to understand. And if there's something weird going on, there's no like debugging of like, what is this being set to? What is R1 at this stage here? There's no break, there's no freezing, there's no inspecting memory and understand what the register is being set to, anything like that. So this is where an external website comes in handy, and I'll show you that. So the first thing is this website is called stationarian.com. Now it's a great little IC simulator system. Basically, this gives you the options to sort of understand what the code is a bit more and play around with it without having to actually, should we say, risk it in a real game. Not even risk it, but just brute forcing it. So under guide, you've got things like here you can look at, I don't know, atmospherics. Oh, if I can spell it. There we go, so atmospherics. In here you can get some basic information. It doesn't give you a lot, but it sort of gives you sort of basic information about the device, but nothing that's actually useful for program-wise, annoyingly. You've got version history, which I think is to do with their tracking of the updates and things like that. But IC Simulator is all we're here for. So in here, this is where you can go in and start programming and things like that. So in here, it's a little bit confusing, I will say, to get the hang of it. Very much sort of chucking it deep end, should we say. So you've got your 5 registers or 6 device registers things here. You've also got DB, which is its own device. So in here we could say, right, D0 will set the field of on to 1. And you could say that mode is 0. And you can see I'm starting to put in some basic information. And here you can then set it to like 1 and things like that. You can toggle the things. So you can type out the sort of device array that you're interested in that slot. So whether you want to know about the color. I'll spell it the wrong way. Right, set that to 1. And you can say, right, I want to set it to color 5, things like that. You can go in and click these things and do all that stuff. Down here again, is the device is the chip is installed on. So this will come in more handy as time goes on with devices being added or slots being added to devices. And down here we have the programming system here. So again, this is the same sort of programming system we have in the game. The only difference here is as you start typing in, you can start typing bits in and it will say, oh no, that does not make sense, and it will actually give you a live debugging. So you can say error, if I can spell, and then I can say up to error. Oh, there you go. So things like that, you can start typing in here and you'll see it activated and doing things and running around. And as you're doing this stuff, you'll see it just, you can interact with it as and when, and you can even share it and things like that from here. You can also run the code. So at the moment it is now run once through its code and stopped. And you can just keep clicking the button and it'll incrementally run through the code once at a time. You can also step it, so it goes through each line and you can see how it's interacting. You can monitor the registers, you can monitor the devices and step it through and things like that. So if you've got something weird going and you think, well, why is it doing that? You can sit here and just step it through one at a time and see where it goes wrong. And you think, well, why does it jump to this line here? And you go, it's because I set this variable wrong here and things like that. So this is a great sort of tool for just getting a bit easier and things like that. You do also have a little bit of instruction set things further down here. So there's lots and lots of notes on here. Again, tons of information on this page. Everything you possibly ever want is all scribbled on here. So this is where you're basically going to get those functions and things like that. Greater than, less than's, break this line or branch this line, things like that. Pull, push, pops, again to do with stacks and arrays and things like that. So all your things are in here. Perfect little cheat sheet that just makes life nice and easy for you. So what I'm going to do is make a simple relay switch. There's nothing too complicated. So state is, or the field is open. Set that to 0 on that. And we'll go down to here and we'll say, right, read in, or actually tell light, load in. So let's clear this all out. Load D1, open, put it into register 0. So I've typed out wrong. I've put the variables in the wrong place. So it says field 0 and field 1 are invalid types, requires either register or an alias, device things. So straight away I've put them in the wrong order. So the register needs to be first in that line. So if we go in there, because it expects this second one to be the device, and the third one to be the thing being read, basically. So that's loaded that into that, and then we say, right, set D0, the on position R0. Let's see if that's right. Yeah, looks correct. And then that's it, and we run it. So now, at the moment, we run through. Is it doing it? There we go. So register got set to 0, and it's now set this to 0, or the on position. So if I set this to 1 and run it again, that is now set the switch or the device to on, basically. So you could then, in theory, have some more clever logic, like depending on the atmospheric temperatures, things like that. You can literally just read it in based on that variable and then doing something if it's greater than, less than, things like that. So, but basically this tool is what makes the game a bit more easy to understand and sort of getting some basic programming bits in. So nothing too complicated. So we're back in game and you can see straight away, starting to see a bit more information now, starting to make a bit more sense of what's going on basically. And it's just going through the logic, stepping by one at a time. Don't be afraid to copy it all, because if you do the copy here, paste that all into here. And then from here, I can then fiddle around and learn set all the variables, things like that, and start playing around with it. And you can see it goes through, and it basically, you can get it to go through and just going through the steps and run everything, run the code through, reading everything in and start and do everything. So you can see it's gone to error state because half the variables haven't been set up here. So, but yeah, this is it. It is basically just going through, spend a bit of time, understanding what the flow is doing, but at the same time, these resources like this website, which will help you to debug it line by line and get an understanding of exactly what's going on. Because as good as this is getting now in game, it's not as easy if you do have a struggle or do struggle with it. So you get an error message when you look at the chip. It'll say error at line . But the problem is that error could have happened 3 steps before. So by taking it into the website coder and going through it step by step, you might see that actually it's branched off and doing something odd and I didn't expect it to at that point, and it's now jumped back here. So that's what it allows you to do. You're allowed to go through with that system and work out exactly at what point the failure happens. And as more devices are added into the game, this is going to become more and more prudent, that basically making little code doesn't have to be complicated and do so amazing things, just something very simple. just like the atmospheric code I've done here, it's nothing I would say amazingly complicated. It's only 35 lines of code. The bulk of it is this bit here. And it is literally just reading in the nitrogen input, working out the filter quantities, because that's just for the extra LED stuff. And I think it's one of the things as well, you don't need to do everything at once. Break it down into small little chunks as well when you're programming. So say I want to just turn it on and off at the base of presence of gas. And this gets onto another topic actually that I've just remembered. And that is controlling the device that the chip is in. So I did run into an issue, and I did actually rant in a recording I did, where controlling the device power. Now, normally with an external chip, you would just simply say on, off, done. But when you turn these devices off, it kills the power to the chip as well. Therefore, the chip cannot turn itself back on when it detects gas. So, this isn't documented in game. It's not very clear at all. So, what you have to do is use mode. So down here you can see filter mode 1, and it took me a little while to work this out because actually the references here we go. So the mode, integer of mode state. Different devices will have different mode states available to them. That's all it says. So even if you look at the device themselves, things like that, mode doesn't actually explain what it does. So it's a little bit of a unknown variable, it has to be said. So you do have to kind of just test things and see. But from what I can gather, it is a case of the mode is a, should we say, a soft power switch, a bit like your TV being put into standby. That is what the mode switch is doing with this filter. And I suspect going forward that more devices will use this sort of soft standby. So the chip still has power and you can still control these devices. Because I suspect all these are doing the same thing. Not quite sure about the centrifuge yet, if that's going to do the same thing. I suspect it will. But again, I'm not 100% sure on that one. So, and these are all the devices I know of at the moment that are doing this function. Amy is slightly different with the mode because I think the mode, depending on gathering, drilling, return, and things like that, I'm not 100% sure exactly what it does in there, but still, there is something probably slightly different again there. So, at the moment, mode is the soft power switch for these devices. Whether or not that will stay like that, whether or not there'll be another variable, whether or not this gets changed in about 2 months' time is another thing. This is sadly just the state of the, well, not so much state of the game, it's just how this game is being so actively developed that things are changing at such a pace that this tutorial might be all expired in about 3 months' time. So, but the code in itself will stay the same, the logic it's going through, the steps are detailed, the website, those things will still work and probably will continue to work because they're the most reliable. Sadly, things like the wikis I've noticed have really fallen behind now, so they aren't any good anymore. I would say they're probably best to, because none of this atmospheric stuff is in there. So the chip stuff, none of that is in there with these new built-in chip slots. So you will have to kind of wing it a little bit and experiment. But start off small, start off controlling things like an LED, as you always do with programming. Start really small, just put text on the screen, hello worlds, things like that, and build yourself up and up and up, and before you know it you'll be doing some crazy elaborate systems that have got automatic satellite tracking and goodness knows what, and you'll be a mad scientist and you just sit in your throne and having food brought to you by Amy. We could only just dream of those days, but hey, we'll see how it goes. Anyway, I hope this sort of gives you an idea of a sort of high level overview of MIPS programming or IC10 programming, and yeah, just sort of give you an overview where to start, where to look, things like that. And then hopefully, as I say, from there you'll be able to then branch off and then overtake me, to be honest, because I can get the basics going, I can get the program to start, but I am not a very good programmer stuff. I can just get it to work, and that's about as happy or about as far as I want to be with it. So anyway, hope you find this useful, and I'll catch you all later. Bye for now.